So hello students, so we have been discussing about chemical equilibria, and now we are coming to the video number 3 on that chapter, and today we will start our discussion with heading number 4, that is equilibrium in chemical process, then chemical equilibrium, that is just the definition of chemical equilibrium, and one more thing we have to discuss over here is the rate of reaction, because later on whatever you are going to discuss in that rate of reaction will play a very important role. So these are the three things that we will discuss in heading number 4. So we begin with equilibrium in chemical process. So when you talk about the equilibrium in chemical process, so first and foremost thing that we need to know is what is a reversible chemical reaction. Reversible chemical reaction is one in which the reactants give us products and the products give us reactants under the suitable condition. So a chemical reaction in which reactants form the products and products give back the reactants simultaneously under a suitable condition is called as a reversible chemical reaction. Now let us give few examples of reversible chemical reactions. So in the examples, number 1 is Fe solid plus H2O liquid. When you heat it at a high temperature, so it gives you Fe3O4 solid plus H2. For balancing, it will be 3Fe 4H2O. Let us see, 3Fe 4 oxygen, and there are 4 hydrogen, and hydrogen will be in the form of gas. So initially Fe and H2O at a very high temperature will start giving you Fe3O4 and H2, and if you carry out this reaction in a closed container, remember whenever I am talking about a reversible reaction, most of the time it is in the closed container. Okay, only in case the reactants and products are in the aqueous medium or something, then the container need not be closed, otherwise it should be a closed container. So they give this, and as the Fe3O4 and H2 form, they start reacting back and give us back the Fe and H2O. The second one, that example that I give is a very famous one, that is formation of H2 gas and I2 gas, H2 gas and I2 gas at 717 Kelvin. They give us Hi, and for the sake of balancing, I will write 2 Hi. The third example that I give you, so H2 and I2 react to give you Hi, and Hi start decomposing and start giving us back the H2 and I2. The third example that I give is of N2O4 gas getting converted into NO2 for balancing to NO2, and then NO2 gas start giving us N2O4. The fourth one that I give you the example is a very famous example, nitrogen gas plus hydrogen gas in the Haber's process, they give you ammonia gas, and for balancing it will be 3H2 2NH3, yes, and then NH3 decomposes to give us N2 and H2. And the fifth one is PCl5 solid decomposes to give me PCl3 and Cl2, and then PCl3 and Cl2 they recombine to give my PCl5. These are the 5 very common examples of the reversible chemical reactions, in which the reactants give us products and then products start reacting to give back the reactants. Now children, in such reactions, what happens is, I have to talk about the rate of reaction. So for the rate of reaction, I have to tell you one thing, that the rate of reaction depends on the concentration. More the concentration, more is the rate of reaction. The simple example is, if on my palm, on the back side of my palm, on my hand, if I put a few drops of dilute hydrochloric acid, dilute HCl, so immediately I will not have any sensation. But after few hours, I will find that my skin has started itching, it has become reddish, and it has started burning. That means it is after few hours the HCl has started reacting. That means the HCl has taken some time to react, and that is because the HCl was dilute. Now on the other hand, over here, if I put one drop or few drops of concentrated HCl, you will find that immediately the reactions start taking place, because immediately you will find that I have started feeling uncomfortable. I might start jumping with the pain and with the burning sensation and with the reddishness, because the hydrochloric acid was concentrated and it started reacting immediately. Which means when the HCl was dilute, it has taken few hours to react on my skin, but when it is concentrated, it has started reacting immediately. From that, what we infer, what we understand is the rate of reaction depends upon the concentration. More the concentration of the reactants, more is the rate of reaction. Now in reversible reaction, initially the forward reaction start taking place and then backward reaction also start taking place. So you think of the rate of reaction, initially the constant of reactants is high, it is fully only the reactants, and as the reactants concentration is very high, so initially the rate of forward reaction is very high. But as the products start getting formed and their concentrations start increasing, the rate of backward reaction also start increasing. Is that okay? But meanwhile, what has happened? Concentration of reactant has decreased. So the rate of forward reaction with the passage of time will go on decreasing. But concentration of product are increasing. So with the passage of time, the rate of backward reaction will go on increasing. Which means with the passage of time, you will find the rate of forward reaction start decreasing and the rate of backward reaction start increasing. And it happens in such a manner that eventually a stage comes when the rate of forward reaction will be equal to the rate of backward reaction. At that time, both the reactions will take place, but they both will take place at the same rate. And that is why apparently you will feel the reaction is not taking place, but that is not true. Both the reactions are taking place, but both the rate will be same. And when such situation comes, when such stage comes, that the rate of forward reaction will be equal to the rate of backward reaction, at that stage we say the equilibrium is achieved. Since we are dealing with a chemical reaction, so that equilibrium will be called as chemical equilibrium. Hence I say the chemical equilibrium, if somebody asks you in simple language, you will say is the state of the reaction when the rate of forward reaction is equal to the rate of backward reaction. Is that okay? And children, I must tell you one more thing, that such equilibriums are dynamic equilibrium. Why? Because nothing has stopped, both are going on. So therefore but they are at equilibrium, so it is dynamic equilibrium, which means when the equilibrium is achieved, the number of molecules of reactants which are getting converted to products are the same as number of molecules of products which are forming the reactants. So number of molecules of reactants reacting to give products and number of molecules of products giving back the reactants will be the same. So this is what is the situation of chemical equilibrium. Is it okay with you? So state at which the rate of forward reaction is equal to the rate of backward reaction is said to be the stage of equilibrium, and since it is in chemical reaction, then therefore it will be called as chemical equilibrium. Now let us understand the chemical equilibrium in little more elaborately, and then we will try to give the definition. Now chemical equilibrium, when you talk about chemical equilibrium. I'll write it a little bigger. So, chemical equilibrium. What I said, that is what I will be repeating with little more illustration or elaboration. Let us consider, so this will be, the word equilibrium will be applicable only when the reaction is reversible. So let us consider a reversible chemical reaction. Let's say in that reaction A and B are reacting to give me C and D, and C and D are giving back the A and B. Is that okay? Now let us consider the forward reaction. The forward reaction, I am writing in like this, forward reaction. When you consider, in the forward reaction, what is happening is, children, A and B are giving me C and D. Now initially I had taken A and B full, whatever I wanted to take, that I have taken, and so therefore concentration of A and B is very high. Therefore initially this rate of reaction is very high, but as the time progresses, the reactants are giving me products, and as A and B are reacting to give me the products, so concentration of A and B will go on decreasing. And as I said, as the concentration of A and B goes on decreasing, the rate of forward reaction also will go on decreasing. Is that clear to you? So with the passage of time, the concentration of reactants goes on decreasing and the rate of forward reaction goes on decreasing. Now let's look at the backward reaction. The backward reaction, if you see independently, so in that what is happening, since I am talking only one direction, therefore I am writing the arrow full, but if the moment I show it reversible, I will show both the arrows half. Be very clear about that. So backward reaction, C and D जब बनता है, तो they start reacting to give me A and B. So C and D react to give me A and B. Now what happens? Initially the amount of C and D was 0, then little bit of formed, and they started reacting. So the rate of this reaction is less, but more and more C and D are getting formed. So this rate of this reaction of C and D reacting to give me A and B is increasing. In other words, the rate of backward reaction is going on increasing with the passage of time. Is that okay? So with the passage of time, rate of backward reaction goes on increasing. This means we realize that in a reversible reaction, with the passage of time, the rate of forward reaction will go on decreasing while the rate of backward reaction will go on increasing. But eventually a stage comes when the rate of forward reaction will be equal to the rate of backward reaction with respect to this A and B giving me C and D, and C and D giving back A and B. So a stage comes when the rate of forward reaction is equal to the rate of backward reaction, or you can also write it as reverse reaction, RR. So you can also show it as reverse reaction. And when that stage comes, we say the equilibrium is achieved. Is that okay? So the state at which the rate of forward reaction becomes equal to the rate of backward reaction, we say the equilibrium is achieved. Now let's give the definition of chemical equilibrium. Now what will be on this basis, you can use your own language and talk about the definition. But before I give the definition, I must tell you, when they both have become equal, now although few molecules of A and B are reacting to give me C and D, but few molecules of C and D are giving me A and B at the same time. So eventually, if you look at it, concentration at equilibrium, concentration of all the reactants and products have achieved a constant value. Is that okay? And there is one thing I must tell you so that you have no confusion. Don't think that there will be equal amount of A and B and C and D. No, nothing of that sort. It all depends upon what is the nature of the reaction. If the reaction was such when where the reactants had more tendency to form the product. So you will find that at equilibrium there is 80% product and 20% reactant. But if the forward reaction tendency was less and backward reaction tendency was more, maybe at equilibrium there will be 30% of reactant and 70% of the product. But whatever it has achieved, that value will remain constant. And this mixture will be called as, when the equilibrium is achieved and everything has become constant, it will be called as equilibrium mixture. It will be called as equilibrium mixture. And individual concentration of A and B will be called as equilibrium concentration. So this idea should be very clear in your mind. At equilibrium, the concentration of reactants and products will become constant, and that entire thing will be called as equilibrium mixture, and individual concentration of every substance will be called as equilibrium concentration. So now let's give the definition of chemical equilibrium. So what will be the definition of chemical equilibrium? Definition of chemical equilibrium. You will define it as, it is the state of a chemical reaction when the rate of forward reaction becomes equal to the rate of backward reaction. Then further you say, at this stage the mixture of the reactants and products is called as equilibrium mixture, and at this stage the concentration of reactants and products have become constant, and each concentration is called as equilibrium concentration. So I repeat, is the state at which the rate of forward reaction becomes equal to the rate of backward reaction. At this stage the whole mixture of the reactants and products, their concentrations have become constant, and that mixture is called as equilibrium mixture. And at this stage the concentration of each reactant and each product is called as equilibrium concentration. Is that clear to you? So we are through with the definition of chemical equilibrium. Now what we have to do is, we have to plot two graphs. We have to plot graphs in the first graph. What I do is, on the y-axis I take the concentration of reactant, product, etc., and on the x-axis I take the time. Now in the beginning, let's say this is concentration of A and B, that is reactant. The entire thing is the concentration of A and B, and in the beginning there is no formation of C and D before the reaction has started. So this is the concentration of C and D, and I am referring with respect to A and B in equilibrium with C and D. I am talking about this reaction. So when in the beginning A and B concentration is high, but with the reaction, as the reaction proceeds, the concentration of A and B will go on decreasing, ultimately it will become constant. That is equilibrium concentration it will achieve. But as far as C and D is concerned, beginning it is 0, but with the passage of time, concentration of C and D goes on increasing, and then it becomes constant. That is equilibrium concentration. So this is one graph in which you have shown the concentration of A and B has gone on decreasing to eventually to achieve the equilibrium concentration. So this stage, when it becomes straight line, you can say it has become equilibrium concentration, and C and D is going on increasing, and eventually it has achieved a constant value, which is again equilibrium concentration. Is it okay with you? So this is one graph in which we have taken concentration on the y-axis and time on the x-axis. Now I will plot another graph, and the other graph that I plot will be this. In the y-axis I take the reaction rate. I take the reaction rate, and on the x-axis I take the time. Is that okay? Now in this case, let's say this is here the forward reaction, here A and B full concentration, so they start reacting, but with the passage of time the rate of forward reaction will go on decreasing, and ultimately it will become a constant value. And rate of backward reaction will go on increasing, because concentration of product goes on increasing, rate of reaction goes on increasing, ultimately it will become constant. And at this stage the chemical equilibrium is achieved. But before that, this is the situation of rate of forward reaction which has gone on decreasing, and this is the situation of rate of backward reaction which has gone on increasing. Is that clear to you, children? So this is the other graph where you are showing forward reaction is going on decreasing, backward reaction going on increasing, and at equilibrium they have become equal. Is that okay? And I must tell you one thing, it is not necessary that it has to be in the middle. This is the graph that you will be plotting in your exam, but just for your extra information I can tell you, suppose the rate of forward reaction tendency is more, there is more tendency of forming product, rate of forward reaction can go like this, whereas rate of backward reaction can go like this. Is that okay? You can also find that tendency of forward reaction is less, so rate of forward reaction can go like this, whereas rate of backward reaction can go like this and achieve the equilibrium. Is it all right? So with that, I think we are through with the graphs. Now what I am coming to is rate of reaction, that is rate of chemical reaction. Now children, when you talk about the rate of reaction, now rate of anything you talk with respect to unit time, you know, your reference point is the time interval, am I right? The rate at which your car is moving, you talk with respect to the unit time. The rate at which you are running, it is with respect to unit time. The rate at which you are eating your food, it is with respect to unit time. So rate is always discussed with respect to unit time. Now when you talk about a chemical reaction, in a chemical reaction, let's say the reactants are becoming products and the products are becoming reactants. But what happens when you talk about the rate, or I will just I will not put the reversible sign, reactant is becoming product. Now with the passage of time, the concentration of reactant will go on decreasing, whereas concentration of product will go on increasing. Now you can measure the rate either with respect to the decrease in the concentration of reactant or with respect to the increase in the concentration of product. So either of this way you can talk. So I repeat once again, you can measure the rate of a chemical reaction either with respect to the decrease in the concentration of reactant or with respect to the increase in the concentration of product. So the rate at which the concentration of reactant decreases per unit time or the rate at which the concentration of product increases per unit time will be called as rate of reaction, and therefore the rate of reaction you can say with respect to D stands for little change in the concentration of reactant per unit time dt or change in concentration of product per unit time, small unit time dt. But here I want to tell you one thing, the concentration of reactant goes on decreasing with the passage of time. To signify the decrease, we put this minus sign, whereas the concentration of product goes on increasing. I can put the plus sign, but I may not put the plus sign. Let us say I put a plus sign. So this minus sign indicates that with the passage of time, this concentration of reactant is going on decreasing. and this plus sign indicates that with the passage of time concentration of product is going on decreasing. So rate of reaction you can denote like this: minus d reactant upon the unit time dt, or plus d product upon dt. The reactant within third bracket indicate concentration of reactant, d indicates the change, minus sign indicates that it is going on decreasing, and dt is the small interval, time interval. Similarly over here, the product within third bracket indicates concentration of product, d indicates the change, the plus sign indicates that it is going on increasing, and dt is the small time interval. This is what is about the rate of reaction. Is it okay, children? So that is all about the equilibrium in chemical process, chemical equilibrium, and rate of reaction. Now going to heading number 5. The heading number 5, we have to talk about law of mass action or law of equilibrium. That we will be discussing in our next video. Okay, children. Thank you. Thanks a lot. God bless you.